Universal Asynchronous Receiver and Transmitter, or UART, was one of the original serial ports, and it was used in this cable that followed the RS-232 standard. This particular cable and its standard, which is RS-232, was heavily used to connect a computer to peripheral, or a couple of computers for that matter, and it utilized the UART as its main communication protocol. However, that particular standard utilized different voltage levels than compared to today's FPGAs, and I believe it was between 3 to 15 volts, or -3 to -15 volts, and today's FPGAs just run between 0 to 3.3 volts. However, the standard itself, the communication standard itself of the UART, is extremely useful and is commonly used today. So what we will do is we're going to construct a new I/O core, and we're going to connect it to slot number 1. And as you probably remember, slot number 0 is always dedicated to timer, and UART is on slot number 1 is always dedicated to UART because it's extremely common and we're going to use it. So UART again is just a form of a serial communication. And generally speaking, a UART module should have a transmitter and a receiver. That's basically what the R and the T stands for, receiver and transmitter, which means that it can send data over transmitter lines. And frankly speaking, what we need to take out of this figure is the following. That the UART module itself has a couple of lines. One is called TX, which is actually transmit, and the other one is RX, which actually receive. And as it turns out, that this particular UART can send all of its data serially, bit by bit, over one of these wires. So if you want to send something from the processor to the outside world, you can utilize this UART to send that particular word, which could be up to 32 bits, one bit at a time at one single wire. So if you're connecting this system to another system using the UART, there are very few wires that you need to do. So if you're sending the word from the processor, which is 32-bit, you do not need 32 wires connected from this system to the other system. And that's the beauty of serial communication protocol. Now, the UART itself is not the only serial protocol. There are actually a lot more. For example, USB is a serial protocol, and actually USB stands for Universal Serial Bus, which serial is in the name. Ethernet is also a type of serial protocol. We don't see a bunch of wires just going inside the Ethernet. There isn't many. There are a few, but there aren't many, like there aren't 32 or 40 or something like that. The UART, however, is one of the slower speed communication protocol. But for our purposes, when we utilize it to display things on the console, or maybe connect some sort of a sensors that utilize an UART. It is extremely helpful. So let me show you a very basic structure of how a serial communication protocol, whether that's UART or something else, actually work. So a UART contains a transmitter and receiver. So you will have a couple of systems trying to communicate with each other over a single wire. So one will have a transmitter, the other will have a receiver. You will take the transmitter line, and you're going to connect it to the receiver line of the other system. And then what the transmitter and the receiver are is really simple things. And what they basically are registers. So the transmitter is just a register that takes some data in. And in this particular case, I'm showing you a 4-bit, but I could have easily showed you about 32 of them if I wanted to, like if I wanted 32-bit. It takes that particular data bit in parallel internally. So it loads that data from the processor or the sending system and whatnot. And then what it does, it actually shifts it out of that register through that wire. So it shifts it one bit at a time. And the receiver is on the opposite side, is also a shift register that keeps getting one bit at a time. So in here, it got the number 1, and then the bit number 0, bit number 1, and then another bit, which its values are basically 1, 0, 1, 1. And what it does after all these 4 shift registers, it assembles this in parallel and unloads it to the processor, or to its own processor, which could be a completely different system. And that's how a basic serial communication protocol works.